Alright, so we are going to start another beautiful, sweet episode of Factorization. I'm going to look at a few questions here, and I hope these questions will be able to resonate with some of the things that we have done at school currently, and hopefully we'll be able to master factorization even better, even more. So we've already done these, guys, from previous live sessions that I've done. If you want to be able to check how we were able to do these factorization problems, you're more than welcome to go to my YouTube channel. The link is in the bio, and you can be able to check out how you were able to factorize using highest common factor, how we were still able to factorize here, still using highest common factor factorization first, because we always check when we're factorizing, is there highest common factor? Then subsequently, after factorizing, taking out the 1, which I insist that people do, then you are left with, in brackets, a difference of what I call a difference of 2 perfect squares. You open 2 brackets, the square root of x squared is x, square root of 121 is 11, and then you write different signs in your bracket, because the difference of 2 squares means you're going to have different signs inside your bracket. We looked at how to factorize a trinomial, a quadratic trinomial, where the constant term is positive. And initially, we always ask, is the highest common factor? We take it out, and then we write what's left over, x squared plus 12x plus 20. We look inside the bracket, and then we ascertain as to what are the factors of 20, which when we multiply give us 20, when we add give us 12. And then we are able to open 2 brackets. Square root of x squared is x and x. The factors of 20, which when we multiply give us 20, but when we add give us the coefficient of x, which is 12, are 10 and 2. And then the signs inside the bracket, guys, whenever we have a positive constant term or last term, it means we will have the same signs inside the bracket. So we looked at that, and then also we looked at a trinomial where there is a negative constant last term. So initially we always ask, is there a highest common factor? There is here, so we take out a 1, and then we write x squared minus 5x minus 24. The constant last term is negative, so that means that if our constant last term is negative, we are going to have different signs inside the bracket. But the factor of 24, that is the highest, will have the negative sign according to the sign of the middle term. The highest factor will always have the sign of the middle term. That applies for when we have a last term that is negative. That means different signs. And it means different signs, but the factor of 24, that is the highest that we choose, will have the negative sign. So the factors of 24 that work here are not 24 and 1. They are not 6 and 4. It's not 12 and 2, but it is 8 and 3. Why? Because a negative 8 plus 3 gives you back negative 5. Okay, so that's how we dealt with that. So if we look at this question in the same vein, this is also a trinomial. So the first question we ask, out of these 3 terms, is there highest common factor? And yes, there is. So I usually say the highest common factor is 1. We take it out, and then what's left over? X squared plus x minus 30. All right. So, I do that as merely a rule, okay, that we always check, is there highest common factor? In any factorization, you always ask first, is there highest common factor? All right. Now, that 1 is not significant. So then, because this is a quadratic trinomial, what do? We open 2 brackets, guys, 2 brackets. That is on the condition that since this is a negative last term, are there factors of 30 which when we add together give us positive 1, but when we multiply them give us negative 30? I repeat, are there factors of 30 which when we multiply give us negative 30, but when we add them give us the coefficient of x, which is positive 1? So that is the question you ask yourself. You only open 2 brackets if that is the situation. Because sometimes, guys, a trinomial, it doesn't necessarily mean that we'll always be able to factorize a trinomial. Some trinomials you cannot factorize, right? So that is the case. Prince, I do have a YouTube channel. You can go to my link in the bio. Sorry, in the bio, I mean, there's a link there. The YouTube channel is also called Maths is a Game. So I upload all these sessions that I've done previously. Like, for instance, I've done 3 sessions already. In the mornings at 6:30 to 7, I usually do a session on grade 9, the aspects of the syllabus covered in term 2. You can check out the YouTube channel. It's Maths is a Game. The link is in my bio. There are 2 links in my bio. There's the WhatsApp channel and there's the YouTube channel. You can actually make sure you join both, because in the WhatsApp channel I post the link of the latest video that I've done of the live session that I covered, and I upload the videos on the YouTube channel under the playlist grade 9 June exam build up. Okay, all right, so like I was saying, guys, so yeah, we open the 2 brackets. After opening 2 brackets, what are the factors of negative 30, or factors of 30, which when we multiply give us negative 30, but when we add give us positive 1. Remembering also that negative last term means we're going to have different signs inside our bracket, and the highest factor is going to have the positive sign. So we have positive, negative. How are we forming x squared? Obviously, x times x will give us x squared, and then all we need are the factors now. So our signs are taken care of, the x squared is taken care of. Now all we need are the factors. So the factors of 30 that we know are 1 and 30, 2 and 15, 3 and 10, 5 and 6. But what we know is, because we know we have a negative constant term, that means we are going to, the highest factor is going to have the sign of the middle term. The highest factor is going to have the sign of the middle term. So if we go to the highest factors for each pair of factors here, we know that the highest factor is going to have the sign of the middle term, and the sign of the middle term is positive, which means all these others, the smallest, will have a negative sign. So the question is, which 2, when I add them together, give me positive 1? So negative 1 plus 30 is not qualifying, so it's out. Negative 2 plus 15, it's out. Negative 3 plus 10, that's out. But negative 5 plus 6, when we add these 2 together, we get what? Positive 1. So this one works. So my factors inside the bracket, guys, is 6 and 5. And truly check again. What's 6 times negative 5? It's negative 30. What's 6 minus 5? I get my positive 1, which is the coefficient of x. So that works very beautifully. I am done factorizing. And this positive 1, which I had initially taken out, is actually still there. Invisible, unseen, but it is present and there. Okay, because every time I factorize, guys, I always ask, is there a highest common factor? Okay. All right, so like I said, guys, those who might be joining in late, the session here, you can check it out on the YouTube channel. It's there. All right. I will actually be uploading it after I'm done. The YouTube channel, the link is in my bio. Maths is a Game is the name of the YouTube channel, but you can go to the link, click on it. It will take you directly to the YouTube channel. You can subscribe. Make sure you hit on the notification bell so that any video that I upload, you can get notification of as soon as possible. So let's look at this now. Move to a different type of expression. Look at this. So in the expression, first and foremost, how many terms do we have in the expression? Okay, so hopefully you guys can see that there are 2 terms in the expression. Why? Because 3k and x minus y, that's 1 term, because 3k and x minus y are combined together by the bracket, so that means 1. Then this minus sign separates the term 4m into x minus y. That's my second term here. So how many terms in my expression? There are 2 terms. Then my follow-up question is, in this expression, is there a highest common factor? And the honest truth, guys, is the highest common factor that we have, whenever we check highest common factor, we need to look at it in the light of the following things. We need to check, is there a highest common factor? What? Sign, number, letter. And then I usually introduce this last letter and I say, is there a highest common factor? bracket. So S stands for sign, N stands for number, L stands for letter or variable, and B stands for bracket. So I'm asking, is the highest common factor sign, number, letter, bracket? So when I look at this, guys, is there a highest common factor in this particular expression? And the answer is there a highest common factor sign? Yes, there is. There's a positive sign. That's the highest common factor. Is there a highest common factor number? If I look at my coefficients 3 and 4, is there a highest common factor number? Yes, guys, there is. The highest common factor number is actually 1. Okay. Then I come back here. Outside my brackets, do I have a highest common factor letter? Is there a letter that is common? The answer is no, there isn't. So there is no highest common factor letter. And then lastly, do I have a common bracket? Let's come here. X minus y and x minus y are common brackets. So therefore, I have to also say there is a highest common factor bracket, and it is x minus y. How do I know x minus y is a common bracket? Please look inside the bracket. Is this bracket the same as this bracket? Let's analyze that. Is this an x? Yes, it is. Is the x positive? Yes, it is. Is this an x? Yes, it is. Is it positive? Yes, it is. Second term inside the bracket. Is this negative y? It definitely is. Okay, and here, is this also negative y? Yes, it definitely is. So both of these brackets are common. They are the same. Thank you so much for the rows. So x minus y being a common bracket means we take out a common bracket. Remember, your highest common factor is something that you take out. So positive 1 x minus y is my highest common factor. So I'm going to take that out. X minus y. And maybe you are sitting there asking, sir, but where is your positive 1? Outside this bracket, my positive 1 is invisibly placed. It is there. All right. I can reveal it. But if the positive 1 is alone, I can choose to just allow it to be there outside the bracket. Now, after taking out a positive x minus y, what am I left over with? What remains, all right, on the left term? So remember, I took out this x minus y. What is remaining on the left side? I'm sure you guys can see. What's remaining is 3k. So I write 3k as my first term on the left, because that is what is remaining after taking out x minus y. I'm left with 3k. That's my what is remaining on the left term. Let's go to the second term, which is on the right. After taking out x minus y, what is remaining on my right side? Remember, this x minus y has been taken out. So what's remaining? I am remaining with negative 4m. And guys, the reason why it's still a 3k that is positive and a 4m that is negative is because when I took out my highest common factor, it was a positive common bracket. So whenever you take out something that is positive, the signs inside your bracket of things that remain the same. All right, and that's very important. Okay, that's done. Factorization complete. That wasn't too bad, was it? Now I want us to go to another common bracket situation. You can see the question, this expression, 3m into 5x minus 7k minus 2n into 7k minus 5x, close bracket. First question we always ask before we factorize is 1. How many terms do we have in the expression? So this is 3m into 5 minus 7k, 5x minus 7k, minus 2n into 7k minus 5x, close bracket. How many terms do we have in the expression? So I hope you guys can count. we have 1. So this is one term combined. The minus sign separates the second term. This is 2. So there are 2 terms in the expression. The second question we always ask when we factorize is there a highest common factor? Now remember, when we take out the highest common factor, we look at the highest common factor sign, number, letter, and if there's brackets, we look at the common bracket that exists. So S, N, L, B. So highest common factor sign, remember, what dictates the sign that we take out as the highest common factor? The first term dictates the sign that we take out as the highest common factor. So you can see, guys, look at this. The sign here is positive. So that means we're going to take out a positive sign as a highest common factor. 2. Number. Highest common factor what? Number. What is the highest common factor number that we have between 3 and 2? It is 1. Highest common factor letter, the M and the N. Which one is the highest common factor between M and N? Guys, there is no common variable, so we don't have a common letter. B. Is there a highest common factor bracket? Let's go and check. Look at the inside of the bracket and ask, are these the same, the brackets? This is 5x and it is positive. The 5x on this side, it is negative. This is 7k, it is positive, it is negative. This 7k, it is positive. So these brackets, are they the same? Are they common? It has to be an absolute no. These brackets are not common. So we have no common bracket. But look at this. This is 5x minus 7k, whereas this is 7k minus 5x. The order of these brackets, if we were to change the order of the terms, we would have a common bracket. So easy for us to have. So what we are going to now do is we are going to come to this second term and we are going to apply something called the sign change rule. We are going to apply something called the sign change rule. I call it the SCR, the sign change rule. Why are we going to do that? It's because we want to be able to make a way for us to have common brackets, because we currently don't. Okay, and the reality is, if we look at 7k minus 5x, it is different from 5x minus 7k. We can't take out a common bracket. Okay, so whenever you have a negative sign inside your brackets, and you can see that the aspects of your terms are nearly the same, but the only difference is the sign. In the sense that it's negative, we use the sign change rule. So what we are going to do, guys, we are going to rewrite this expression. And what we will do is we are going to change the sign outside our bracket, positive to n, and then we are going to change the order inside this bracket. And look at me go. 5x minus 7k. Now I'm sure people are looking at me and they're like, what did you just do? You changed the sign outside your bracket from negative to positive, then you changed the order of the terms to 5x minus 7k. How does that happen? And I want to explain how it happened, guys. The way that this happened is, if I have 7k minus 5x, okay, if you have 7k minus 5x, Kamo, you were 100% right. That's very correct, right? I need you to understand where it comes from, though, so that even you can explain it the next time, okay? So if you have 7k minus 5x, say I took out a negative sign and then I rewrote the 5x on the right this time round and the 7k on the left this time round. What exactly actually can I then conclude? Remember, if you took this negative sign that you took out and you returned it back to the bracket by simplifying, you distribute the negative sign back. What's a negative times a 5x? Doesn't it give you back the negative 5x? If I take the negative sign and I distribute it back, yes, it does. And then if I take the negative and I distribute it back to the negative 7k, doesn't it give me back the positive 7k that I originally had? Oh, it definitely does. So this is something that we can apply whenever between two terms there's a negative sign in between. We can simply change the sign outside the bracket, close brackets for both the terms, and then change the order without actually considering the sign. We leave the sign as it is, but then we change the order of the terms inside. 5x comes this side, 7k goes that side. Because when I take the negative sign that I've taken out, if I distribute it back, I get my original expression back again. Okay? So that's what we call the what? The sign change rule. So simply put, this negative sign would have to what? Change in order for us to be able to do what? In order for us to change the order of the terms. Because remember, we are taking out a negative sign, and this negative sign that we take out, what happens to it when it is multiplied with this negative sign? It becomes positive. So then that negative sign you took out then allows you to change the order of the terms. Now you have 5x as your first term and 7k, which is negative, as your last term. And that's 100% correct. Now we have common brackets. Now I can go back and say, what's my highest common factor sign? It's positive. My number, it's 1. My letter, I don't have any letter that is common because m and n are not common. Then my bracket, I can now write my common bracket as 5x minus 7k. And remember, it's a positive 1, 5x minus 7k that I've taken out. And that's beautifully done. Okay, so I'm very sorry, Kamo, that for some reason or another, that maybe have been said to you that it's incorrect, but it's 100% correct. Okay, no, Shana, the brackets don't cancel each other out. Shana, they don't, and I'm going to explain why. Okay, Patiyumata, yes, Kalogo, when you take out, remember when you, and this is what I usually say to my learners at school, all right, you change the sign, you change the order. Okay, Shana, I think you are confusing two concepts here, and I'm going to explain just shortly. Shana, you're going to have to stay with me. Shana, you are confusing two concepts, and unfortunately I'm going to have to go very soon. But after taking out 5x minus 7k as the common bracket, what's left over on the left? We are left with 3m. Okay, remember, it's like we took out the 5x minus 7k, so what's left over on the left? 3m. Then we took out the 5x minus 7k. For the right, what's left over? Okay, can you see what's left over, guys? If I hide my 5x minus 7k, what's left over on the right? I'm left with positive 2n. And that's me done. Factorized this expression. Okay, guys, please, tomorrow morning I'll be having a session again at 6:30 to 7. I have like a mini sessions for grade 9 on this TikTok platform, a live lesson. So every morning just before I go to work, I do a session so that you guys can actually have a bit of revision, if you will. I also want to, you know, hammer in some of the things that you've learned in grades. Okay, I just want to look at this example quickly because I think Shana is confusing this. This is factorization, remember, factorizing. All right, so if you look at this question, we are told here to what? To simplify. Now, when we simplify, guys, I hope you guys can see these questions, all right, because this is what I'll be doing with you guys tomorrow. Okay, so take note of these questions. Shana, these are the kinds of questions where you cancel, because division. Okay, let's say for instance I have x plus 4 over x minus 4 into x plus 4. Okay, Shana, if I'm asked to simplify this thing here, x plus 4 over x minus 4 into x plus 4. Remember, this x plus 4 in the denominator and the numerator is common. And we are dividing, Shana, remember. So x plus 4 divided by x plus 4 is actually, what is something divided by itself? It gives you 1. So when you are dividing, you get left with 1 and 1 in the numerator and the denominator. We cancel. Alright? Okay? So that's where cancellation happens, because you are dividing something by itself. And then your answer here would be 1 over x plus 4. Because when you cancel these two, remember at the top you are left with 1, at the bottom you are left with 1 with this x minus 4. So your final answer would be 1 over x plus 4. Okay? Right. Okay, guys, so I'm going to love and leave you. Thank you so much. It was great having a session with you. See me tomorrow morning, 6:30, same time. We'll be picking it up from where we left off with more factorization and also simplification questions. And then what we are going to do as well is we are going to continue where we left off. Go to my YouTube channel if you want to check out more things. Shauna, since you're in grade 11, there are grade 11 videos that I've done on my YouTube channel. You can go to my link. There's a link in my bio. And there's a playlist for grade 11s. I've done live lessons here, and I've uploaded those live lessons, interactive lessons with some of the grade 11 kids that I've done here on the platform. And you can check those out. For all the theorems, I did like sessions so that people can actually get the basics as well, if you know what I mean. Okay, guys, thank you so much. It was great. Have a good one. I'll see you tomorrow again. And yes, go to my YouTube channel. Please do subscribe and check out the live lesson videos that I've done there. There are playlists for the grade 11s for topics that I've done so far. Cheers, have a good one, and I